This conference will now be recorded.
All right, everyone. Thank you so much for joining the demo session this morning. So let's get started. Welcome everyone to this demo session. Before we proceed about me, so I just want to put it in an interesting way. So I put it in a YAML file. So my name is Kiran Kumar, and you may call me Kiran. I have a total experience of 13 years, out of which I've been working as a DevOps engineer for the past 7 years. Okay, my expertise lies in cloud and infrastructure as code. I worked in uh, multiple cloud environments, particularly AWS and Azure, and my interests are, latest technology and training folks. In my previous organizations and even in current organizations, I gave a lot of internal trainings, and I've been teaching through Career IT from the past few months. Okay, and it's been a great experience so far. So that's about me. I work for a startup right now. All right. Uh, shall we move on? So in this demo, I'm not going to ask you all to introduce because, as you know, it's a demo session. But once we start uh, our regular classes, maybe I'll get introduced to each of you, uh, maybe by batches of three every day. All right. Next, the obvious question. So I'm going to straight go into that question. What's this course about? So this course is all about understanding IT infrastructure, its architecture, various stages of application lifecycle, gaining insights into cloud computing, learning to use and implement infrastructure services on Azure, and to learn the concepts of DevOps practices, tools, and techniques to implement DevOps on Azure. Okay, so that's in a very nutshell. We will understand how IT infrastructure actually works, how the network looks, how the overall architecture looks, what are the various components, and what are the various stages of application lifecycle, and we understand what's cloud computing, and we also um, start using Azure services, and we'll learn DevOps concepts. We'll learn about various tools that make DevOps possible, and we will implement that on DevOps. That tools and techniques on Azure after we have the basic understand not basic understanding, after we have good understanding of Azure infrastructure services. Okay, any questions so far about me or?
Yeah, I have a question. I'm Hari Krishna. I've
Mhm.
got invite from Ramakrishna. So, what
Okay,
type of background do we need to learn this DevOps and all these things? Because
okay,
I've been
that's a
working.
good question.
Yeah. Go ahead. Go ahead. I think I don't want to interrupt you.
Yeah, so you could be a total fresher, or you could be someone with an experience in IT industry, or a totally uh, you could say associated IT industry, like a project manager or a QA engineer. It doesn't matter, but if you would like to learn it and with full enthusiasm, you can join this course and practice every day, and you would be in a position to uh, say that you have good experience in DevOps. But that all depends upon how much you practice. So if you're someone already working in some roles like production support or QA engineer or database administrator, these people might have a little advantage because you might have some understanding of how IT infrastructure works and all that stuff. But even if you are not related to IT, it shouldn't really be a big problem. But the point is you have to practice intensely.
Got it. And also one more thing, like I'm an ETL engineer. I'm basically not a I'm a ETL engineer, and I'm working as a tech lead on the ETL side.
Mhm.
So how much programming is needed for this? Like what type of program is needed for this DevOps to be an expert in DevOps? And
All right. So DevOps, as you know, I mean, and we will speak about that as well, is all about automation,
okay,
or how do you minimize human intervention in the various tasks you do. Okay. So there would be some level of scripting that is required, and we will talk about scripting in our course. Okay. Uh, but if you know a programming language like Python, for example, that would be an added advantage. But that will be again in your what do you say, good to have skills, not the mandatory skills. uh, we will do some coding, we'll learn some sort of YAML and other languages, I mean some configuration languages, but programming is not like a prerequisite for DevOps. Yeah, but I would all, I would request you all to understand that DevOps is all about automation, which is again about uh, getting things done through coding rather than through UIs and other stuff. So it would be in your best interest to start practicing scripting as soon as possible. Maybe in Bash scripting is fine. Okay. Yeah, we'll come to that part in this demo. Don't worry. Does that answer your question, Hari Krishna?
yeah, that's good. I was able to understand.
Yeah, sure. Okay, moving on. So first, let's get started because this course is all about DevOps with Azure. So Azure, as most of you know, is a cloud. So first, let's understand what's a cloud. So cloud computing is the on-demand availability of computing resources without the active direct management of the user. In other words, cloud is a collection of data centers managed by a cloud provider, and users can rent resources on a pay-as-you-use model without the upfront costs. Okay, so this is all very theoretical, but what does it mean in real life? Let's see. Okay, uh, let's say you want to start you have a good idea about starting uh, some business, online business. Okay, you would like to sell you are a good manufacturer of handicrafts, you make some nice handicrafts, and you want to sell them, and you also happen to be a programmer, so you can write your own website. But where do you host this website? You cannot run your application from your laptop or desktop, right? You would need a server, right? So to host your website you would need a server, and the server needs to have network connectivity, and you need to have the network connectivity all the time, because when you're running a publicly available website, you cannot take a chance and say, at 2 p.m. your server can go down or your application is not available. You cannot have such situation, right? So what you need to do is you need to ensure you have redundant power network connectivity, meaning more than one network provider. You need to have redundant power connectivity, meaning you need to have an inverter, you need to have a uh, maybe two inverters if one inverter comes off. So you need to maintain all these redundant network and redundant power connectivity. And going forward, if your load increases, you'll need to increase number of servers you have. Okay. And IT best practices says you have to separate your application, your web tier, and your database into separate layers. Okay, so maybe sorry, DB. So again, you'll have to buy more computers, and you have to maintain them in a warehouse, because all of these will generate a lot of heat over the period of time, right? So you need to maintain a separate room with cooling, again with physical protection and all these things. So this becomes a lot of cost for you. So to run a simple web application, you need to maintain so many resources and so many physical infrastructure. You understand physical infrastructure, right? You have to actually buy real physical servers, then you have to buy routers for them and all this stuff. But come cloud, post 2010 at least, you don't have to worry about all these things. You have a good idea, you want to start a website, all that you need to go is sign up on aws.amazon.com or azure.com and spin up servers on demand. Okay, just ask for a server, it will spin it up for you. You can use some tools to access the server as if it's on your local machine, and you can install your software, you can bring your code here, everything, and your server is ready. Let's say you're doing a POC, POC, proof of concept, where you want to understand how well your application works. So you can test it, and once everything is working, you can simply delete this server. It's no more in use. Okay. Tomorrow, after a few months, you thought your concept is good and it works, then you could spin up and show it to some investors. Okay, you could spin up two servers and spin up a load balancer, which is a networking device, and you can showcase this to your investors, saying that, hey, this is my product. I mean, you won't show your servers and all. You'll directly show your website, but your website is running on Azure, for instance. So you need not buy your own servers just to do some presentations to your customers. You can rent infrastructure on Azure and show them that, okay, this is my product. Okay, how do you feel about it? If you find investors after your demonstration, again you can delete these servers because you have your code with you. Anytime you can deploy that. Okay, again, your investors come back to you and say that, hey, we are good with your proposal, we can go back, we can start our business. Then you can start as many servers as you want from Azure without paying anything, because the billing will start. It's like your postpaid connection. You need to start paying after you start using it. Okay, so without any upfront cost, you can start your application on cloud and you can make it available to the public. This is what we call on demand availability of resources. Okay, so yeah, let's forget about servers and all for a minute. Let's talk about another factor that we all face in real life. All right, let's say you are a retailer, not an e-tailer, not an online, but a real retailer. Like you have a nice textile shop. Okay, some babu collection or whatever it is. So you would need a space to store your garments. Okay, you have a front end, which is your shop, but you need a back end, which is your data, your warehouse, where you actually store your clothes. Okay, so let's say you hired a godown of 100 square feet. Okay, you hired a godown of 100 square feet, but most of the times you use only, let's say, 40 square feet of it. Okay, because that's enough for you. 40 square feet should be enough for you. What's happening here? You're just using 40 square feet. Excuse my drawing. But why did you hire 100 square feet? Because this may be okay till December, but December you have Christmas season, or let's say October you have Dasara season, and you would require 70 square feet. So you cannot go to another godown at this point in time. So you actually hide 100 square feet, because for 2 to 3 months you might use 70 square feet, right? But even then, you're still wasting 30% of your space, right? Most of the year you're using only 40 square feet, which means 60% of your godown is underutilized. And because you have a peak demand in December to April, you you hired 100 square feet one, but even then you have only 70 square feet of uh, utilization. Your 30% is still underutilized. Maybe at one point in time you might go to 90% for 1 month. Rest of the time it mostly lies here, 40 square feet on. Okay, So in real life, we might not be able to do much about this because you cannot hire another go down only for your peak season, because right, real estate is costly and owners will have long-term deals and all. But thankfully, in computing situation, this can be easily solved. What I mean to say by this, let's say you are a e, what do you call e-commerce website. You have your own website, and you know that you need only 6 servers, okay, to run your operations. Okay, so you can keep it at only 6 servers. But if you are not on cloud, if you're using your own data center, you will have the similar problem. First of all, you will buy 6 servers. Okay, you'll start with only 6 servers, but you have to have a physical room for them and physical security, physical cooling, everything. Okay, you started with 6 servers, so your demand has started growing steadily, and now you more users are coming to your websites. So you decided you will have to increase it to 8 servers. Okay, you increase it to 8 servers. That means you have to buy additional hardware, you have to make additional space. If the room is not available, you have to rent a separate room, you have to put the cooling and everything. Okay, let's say it even more steadily grew up to more customers coming, and you have now you have to buy now 10 more server 2 more servers, which makes it 10 servers. Okay, you bought 10 servers over a period of time. But after a period of time, your website competition has increased and your demand has come down. Now all the servers are not being utilized so much, so you decided at least you will save on power cost and decrease the servers to 7 servers. Okay, but here in this case, you already bought additional space because your physical servers have to lie somewhere. So what's happening is your 7 servers are being utilized. Okay, and the 3 servers lie unutilized. Okay, and it's when you, unlike the physical, unlike other things, when you have your servers, you cannot simply ignore them. Okay, you have to power them on from time to time and do upgrades. You can shut it down for the most of the time, but when you have upgrades, you need to run them and do upgrades and all that stuff, and you are already wasting some space. You cannot simply move them into your garage or somewhere. You still need to keep them in your cooling, in your server room. Okay, again, let's say it even further decreased, your load has further decreased, or you say you increase the efficiency of your code and you need only 6 servers now. So you're wasting these 4 additional servers and you're wasting the space for them, and you cannot simply junk them, because if tomorrow demand increases to 8 servers, you cannot buy new servers again. Okay, this is on the when you maintain your own servers. But think about cloud. Cloud is very elastic. As I said, you can start with just 1 server or 2 servers. Okay, you don't need to have any space in your home or anywhere. You just need to buy. These are all on cloud, literally, I mean, on the internet somewhere, maintained by Azure. So you can start with 1 server, and if the load increases, you can go to 2 servers. Okay, you can further increase it to, let's say, 10 servers if you got good demand. But at a point in time, let's say your demand has come down to 6 servers. So as opposed to your server, the situation where you're managing your own servers, here you need not worry about your physical space and everything. You can simply decrease it to 4 servers. Okay, and forget about these 2 servers that will be deleted and gone forever. Okay, you need not worry about it. If you want to sort of increase your capability, again you can do it without any additional cost, without buying any infrastructure, and you will start paying only for that time when you started adding the new servers. For instance, just seeing if anything is on chat. Okay, so let's say you have to, where am I? Yeah, sorry. Yeah, if you're using 4 servers, let's say till March 15th, and from March 15th you've increased 2 more servers. Okay, for these 2 more servers, you'll only start paying from March 15th only, not to the entire duration. Okay, that is what we call as pay as you go. We'll start only using from billing from March 15th, and until March 15th, you will be billed only for these 4 servers. Let's say after April 15th, you started removing these 2 servers, so you'll be billed only for these 4 servers, and those 2 servers will not be billed anymore. So this is what we call as pay as you go. So if we see what are the important characteristics of cloud, one thing is pay as you go. You will pay only for as many resources as are using, no upfront cost. Primarily, you need not buy any servers straight away. You can start using and pay at the end of the month. Okay, and elastic in the sense you can go from 1 server to 10 servers or even 100 servers. 1000 is little far-fetched in a matter of minutes. Okay, and also you can scale down. Scaling down is bringing down your number of servers from 100 to 10, again in a matter of minutes. Okay, so this is what we call as elasticity. Okay, cloud offers all these things. So cloud is all about renting resources, computing resources. When I say computing resources, what are those computing resources? These could be computers, these could be uh, networks like routers and all these things, load balancers, and your storage as well. If you want to store your data about your users, you can buy hard drives from, not buy exactly, you can rent hard drives from Azure. These are all virtual resources for us. Okay, we can only access them through a website and upload our data there, but the data is there for real. Okay, all right. Cloud is very elastic. As I said, it can go up to so many number of services. And also, let's take another scenario. Your website has got real good, I mean, your website has gone really well, and it has got so many users per month. Now you would like to understand which category of products users are buying a lot. Let's say you're a e-commerce site like Flipkart. You would like to do some analysis. Okay, and you have lot of data, right? Lots of users visiting, lots of clicks, everyone going into this section, that section. You want to understand which section people are visiting most often and at what time. Then maybe you will need a machine with a very high power, like 40 vcpu 40 cpus, 40 cores of cpu. Okay, and 100 GB of RAM to run some machine learning algorithm to understand where your customers are focused on. But imagine buying this computer in real time. It will cost you a lot, or you have to buy a lot of small computers and cluster them into a single computer, which is again lot of cost and lot of effort. But you can provision this, and let's say you're using this machine only for a few minutes in a week or few hours in a week, because you just want a report and then you can shut this computer down. So cloud also offers this kind of elasticity where you can spin up a very high powerful machine and use it for a couple of hours or how much so ever time you require, and just shut it down and take your data from this and save it somewhere. So that's how simple it is to actually spin up such strong computers and do your computational, I mean, use your machine learning programs to understand where your customers are going. So that's why cloud is on demand because of some of these features. Okay, so that's what I meant to say here. So on-demand availability without the direct active management by the user. So what does this mean? Without direct active management by the user, in the sense, uh, let's talk about another kind of applications, Ola and Uber, right? Earlier, if you have to book, I mean, if you're old enough like me, if you know Z cabs and all that stuff, you have to call them one day earlier and tell them, okay, tomorrow morning 10 a.m. I would need a cab at so and so location. Okay, but today, if I need a cab at 10 a.m., I wake up at 10 a.m. and I can start booking at 10 a.m., right? So this is also like that. No direct active management by the user. You need not pick up a phone and call someone or send an email. You can directly log into Azure's or AWS site and start spinning up your resources. Okay. So cloud is nothing but a, as I said, we are spinning up servers, but they must be located somewhere, right? And all these data centers are managed by your cloud provider, and you rent them on a pay as you use model. That is, you'll start using them, and you'll pay only for the time you use it. If you're using for 15 days, you'll pay only for 15 days. All right. There is no upfront cost. You need not give any money at the start of the month to start using resources. Okay. Right. Next, what is Azure? Azure is the Microsoft's cloud offering. Okay. In the cloud computing arena, we have a lot of players today, and AWS, Amazon's AWS is the premier, or what do you call, pioneer. He started way back in 2006. Microsoft started somewhere in 2010. Okay, it is one of the leading cloud providers, only behind AWS in market share and service offerings. So if you look at the market share, meaning number of customers that are using cloud providers, AWS obviously is the leader, closely followed by Azure, and then Google Cloud Platform. Okay, and even in the number of services, it is the strongest competitor to AWS, because there are a lot of cloud services, not just servers and routers these days. You have a lot of infrastructure, you have a lot of machine learning services that can be rented. Azure's infrastructure is spread across the globe in 54 regions and 140 countries. So Azure has its data centers, physical data centers from where you can spin up your resources at 54 regions and 140 countries. Okay, Azure services span various areas from virtual machines to storage, machine learning programs, IoT, big data, and security, and many more. Okay, let's suppose you want to implement some IoT solution, you can do it on Azure. You want to do some big data analysis, you can use Azure solutions. Okay, any questions so far? So someone has a question on Azure. Can you discuss on more Azure account and costing? I want this if possible. Okay, sure. Yeah, there's nothing much I talk on billing and accounting. That will be for later section in the course. Okay, because this course aims, I mean, this demo aims to give you what I'm going to teach the entire section. So that's why I'm giving you some overview. All right, next comes, yeah, the course is DevOps with Azure. So we talked about cloud, we talked about Azure. Next thing is DevOps. What's DevOps? Okay, so anyone has any idea what's DevOps? There's no right or wrong answer, so you could speak up.
When development and operation team works together.
Yeah, that's pretty much, yeah, that's a good answer. Anyone else? Okay, yeah. Before that, we have to understand a few things. What is software development lifecycle? Before we go to actually understand DevOps, let's understand software development lifecycle for a minute. So every system needs a life cycle. So this could be also called as system development life cycle. When I say system, it could be anything like a building, uh, like a metro rail project. Anything will have a life cycle. It will go through planning first, then you define, you design, you start building, testing, and you bring it to production, meaning you will allow it public to use it. That's called deployment. Okay, once you start allowing, so once you start plan and you define what you're going to create. Okay, so define is like, how many servers do I need, how many what application I'm going to build, where am I going to build, and all these things. Then design, how are my applications going to talk to each other, or what are the various components will come under designing. Then building is, you actually start developing these things. Okay, as a proof of concept first, maybe. Then you test it. Once you test it and you see that it's working perfectly fine, you actually put it in deployment. Okay, so what is software development lifecycle? Software development lifecycle is the process used by IT organizations to plan, design, implement, maintain, test, and deploy software applications. All right. So every application, if it wants to go live, it will go through all these phases. Okay. The SDLC aims to produce a high quality software that meets or exceeds customer expectations, reaches completion within the times and cost estimates. Okay. So why do we need to have a life cycle? Because the aim is to provide high quality software that meets customers expectations and reaches completion within times and cost estimates. Every project has time estimate and cost estimate. So if you start a project today, it needs to have an estimate like I will go live by, let's say, October, and I will use only $200,000 or $100,000. So this software lifecycle, the software development lifecycle ensures that these are met, that you build the software within time, and you also use only the estimated budget and not go over it. Okay. So earlier there was this there is this method called as waterfall method, where everything went sequentially. First you gather requirements, then you start designing, then you start implementation, then you start verification and maintenance. Okay. Um, this was a linear process. For instance, once you come to design state and your customer says he has some change in the requirements, you would say, hey, wait, we have already in the design phase, we cannot go back. So I need to implement this, verify this, and bring it to development, bring it to production and maintain it. Only then we can go back to your new requirements in the next cycle. Okay. That was the waterfall method, very rigid in a way. You have to go linearly. Okay. So this is not really helpful because requirements might change quite often, and uh, anything would happen while you are still in the design phase or even in implementation phase. So this method has become very rigid. So around 2000, I think, a new model has come across, which is called as agile. Okay. So what is agile is, the word agile itself means moving fast and moving with grace. Okay. So you should be able to adaptive. Okay, so in this agile process, what it says is you might be already in analyzed plan, and you came to plan, but again you can go through multiple iterations. In the sense, okay, you started building something, you designed it, you tested it. There might be some rework on plan because of what you observed here. You can go back to planning and again start this cycle. Okay, again you deploy it, and again you analyze it. So how is my product working? Are there any bugs? Is there anything I could do to make it work effectively? Then again you plan it, and you again go through these cycles. So this gives you options to iterate more often. Okay, and make changes very soon. And what something else that agile recommends is, it recommends to start early and then keep on making changes incrementally. What do I mean by that? You all use WhatsApp, right? Today most of us use WhatsApp. uh, so let's say, when was WhatsApp launched? 2013. So when WhatsApp launched, it had only one feature, text messaging. Okay. Over a period of time, let's say this is the timeline, they started adding new features like voice message, rather image sharing, voice message. What else we got? Then they introduced calls. Then they introduced video calls. Then they introduced uh, status. Then they introduced picture in picture video. Now then they introduced swipe to reply, making it easier. What else? Now they got something for WhatsApp for business. Okay, this is 2020. Maybe I've missed a lot of features, but let's assume these things. Okay, so these all happen over a period of time. So when WhatsApp started, it started with a very basic feature like text messaging, and then it keep on incrementally adding lot of features over the period of time. Let's say WhatsApp, instead of releasing in 2013 with just text messaging feature, it might have thought, okay, just text messaging won't work. They already have SMS. Let's combine all these features. Okay, let's work on all these features. How much so ever time it takes. I will still work till 2020, and on 2020 I'll release all this at once. Okay, directly on 2020. So in 2013 you don't have anything, you don't have any of these things. Directly in 2020 you want to launch all these features. Okay, what would have happened if WhatsApp had done that? Instead of launching in 2013 with a simple feature, if WhatsApp waited till 2020 to develop all these features, what would have happened to WhatsApp?
No, nobody's going to subscribe it.
Exactly, because competition would have overtaken it. Telegram would have overtaken it. Hike, WeChat, which have all bit the dust in the last few years, they would have been hit than WhatsApp, because there are a lot of competitors who have already come here. So that's why Agile recommends that you start early, okay, with whatever features you have, minimum viable product. Then you keep on adding incremental changes over a period of time and do it faster. Okay, earlier, if you're using Android phones, you would get updates once in 3 months or something like that. But if you have noticed, you get it every uh, fortnightly, sometimes every monthly, sometimes. Okay, every application is doing more and more changes. They are bringing in more changes because they have been following this agile methodology. Okay, so that's what agile methodology suggests. Start early and start trying to iterate as many times as possible, and it gives you the flexibility to go back. That's about agile. Why are we learning about agile? Okay, see, agile advocates adaptive planning, evolutionary development, early delivery, blah blah blah. Okay, it encourages rapid and flexible response to change. This is important. Encourages rapid and flexible response to change. Okay, so there is a change in your requirement. The agile framework offers you the flexibility to go back and say, okay, I'll go back to my planning phase and I'll continue my design later. Okay, so why am I telling about agile? Because this has changed the way the IT world has been operating. So to cope up this pace, this is from the developer's perspective. This is how developers develop their applications. But there is other side to this. Your developers only write code, and every application in the beginning is in the form of a text file. You know text file, right? Just like this, letters, numbers, and words. Okay, or some special characters like your C program. Everything is like a simple text file in the beginning, your WhatsApp application or your YouTube application. But that has to be converted into a binary and deployed into servers. That's the second part. This is where the operations folks come. This is where the concept of DevOps has come back. Okay, so this thing is called as XP or extreme programming. The agile methodology has brought this extreme programming where people started developing applications faster. So the other part should also meet this demand, meaning the DevOps or the operations team should also be equipped to do this, take the new changes and put it in the hardware or the virtual hardware quickly as possible. That's why the culture of DevOps has come into picture. Okay, let's see what DevOps actually is. DevOps is a set of software development practices that combine software development, which is development, and information technology operations, or shortly ops, to shorten the system development lifecycle while delivering features, fixes, and updates frequently in close alignment with business objectives. Okay, so your business objective, so you can deliver what type of, you can deliver any types of updates, but they have to be in alignment with your business objectives. Okay, so this is the keyword for me: shorten the systems development life cycle. Meaning, from the time you think about starting a project, from the time it goes to market, that is your total system development life cycle. Okay, from the time you have an idea in your brain, from the time you actually make it go live and everyone can use in the public, that's the system development life cycle. So that has to be shortened. You have to make sure your product goes to market as soon as possible. So only the developers developing the code in a real short time is not enough. That has to be taken, uh, that has to be packaged and put it into a server and send it to, make it available over the internet. That's the IT operations work. Okay, so the DevOps is a practice that aims to bring these two teams together. Okay, and make these things happen quicker, from the time you start designing a project to the time you go to market. That is called go to market time. It has to be shortened. Okay, that is the primary aim of DevOps. So what is DevOps? Is it a tool? Is it a set of tools, or is it some programming language? It's none. It's not a tool, it's not a programming language. It's actually a set of practices. Okay, as it says, software development practices. And what is Agile and DevOps? Okay, yeah, I think this has been jumbled. This has to come up first. We've already understood what software development lifecycle is. Okay, we've already discussed this. In earlier, waterfall method was followed, so it was very slower, and IT operations teams also need not be so quicker. So the waterfall model is a breakdown of project activities into linear sequential phases, where each phase depends on the deliveries of the previous one and corresponds to a specialization of tasks. So unless your previous task is completed, you cannot go to the next task in waterfall methodology. In Agile, each phase can be seen as an independent phase, and you can still start working on the next phase while the previous phase is still going on. Sorry, repetition. So theoretically speaking, DevOps is not a role. It's a culture that aims to create better coordination between development, QA, and operations, and speed up software release with utmost quality. Okay. So, what is software release? As I said, today you might have a product, but your developers or your designers came with a nice, nifty addition to that. Okay, which could attract more customers, which could beat your opposition. So once you have this feature in your mind, it doesn't take much time for your competitor to develop the similar one. So the challenge here is not to have a great idea, but put it into production as soon as possible. That's when the DevOps comes into picture. It aims to uh, shorten the development life cycle and make the software release quicker. Okay, so I said DevOps is not a role. There is no such role as like DevOps engineer, like a .NET developer or a .NET Java programmer. But in reality, we do have titles called as DevOps engineer. For example, the role I'm working is called as a DevOps engineer. Okay, so that's there's always a gap between theory and practice, right? DevOps is always uh, a practice in theory, but in reality, you will see roles called as DevOps engineers. Okay, and there is a book called there is a book called Site Reliability Engineering by Google. Okay, they've launched their Site Reliability Engineering. So they say DevOps is always not a team, not a uh, role or an engineer. It is rather a practice. Instead, you should name your team as Site Reliability Engineer. Okay, but again, some teams name it as Site Reliability Engineer. Some organizations still need DevOps, still have the title of DevOps Engineer. But the primary aim of adopting DevOps culture remains the same anywhere, is to build and release software quickly and maintain applications with high availability and resilience. Okay, these are keywords. What is high availability? To make sure your application is available throughout the year. Okay, and any systems are prone to failures. So has WhatsApp ever gone down? Yes, it has gone down a few occasions. So meaning they still have very high availability. But even in those occasions when it has gone down, like it has gone down in January, I guess, for a very brief minute. So the ability to get back to your production as soon as possible, or get back to your normal state as soon as possible, is called as resilience. You might fail, or there might be a temporary failure. So how soon you can recover is your resilience. So the DevOps culture is about not only building quality software and building it quick, but it's also about maintaining your applications with high availability and resilience. Okay, and all this means to bring up the software faster to market. All these means you have to automate your systems. Sorry, there's a lot of repetition. I don't know why, or rather am I going up? Okay, so if I think about splitting, all right, so we talked about DevOps being practice and all this stuff, but just thinking about DevOps as a practice doesn't suffice. It needs to have the tool chain required to make it possible. Okay, so I mean, this is something I've drawn over a period of time, but it is still subject to change. But over a period of time, when you notice, there are various sectors within the DevOps, and each section needs some automation. Okay, for instance, you would need infrastructure to run your applications. You need servers. They could be physical servers or they could be running on cloud, but at the end of the day, you need infrastructure. And then you need to configure these servers, meaning you need to install some software, some OS, some network changes, and everything. You have to configure the software. That's the next part. Then I'm not talking about the development side. This is from the perspective of what do you call a DevOps engineer. Then you have to build the code. So developers build the code, and you need to take this code and build it. Build it in the sense, for example, as I said, every application at the initial stage is a set of text files. Okay, text files in the sense, uh, like your what you write in notepad, like your C program or Java program. But this cannot be run on servers directly. It has to be converted into a sort of binary. Okay, like a Java if you're running in a mobile application, it has to be converted into APK format. If it's an iOS application, you call it as IPA, I guess. Okay, so somewhere you need to build it into an executable that can be run on your servers or your computers. So that's the build process. Okay, you build the application, then you need to release it to the market, either through Play Store or if it's a website, on your website. So this process is called as release. So now you've released your product to the market, everyone is accessing. You need to continuously monitor and also have an alerting mechanism. I mean, when you monitor something, what's the use when you don't get alerts? You cannot sit in front of your monitoring system and see when is the computer going down, like you sit in front of CCTV. You have to have some sort of alerting which will send alerts when things go bad. Okay, so these are the various components in the software development life cycle from the DevOps perspective. And also there's another component that is visible through all these things, like your software configuration management, all these processes, your version control system. Version control system is how you store your software. Okay, like you need to version them and you need to keep them in a central location. That's the version control software. That is invisible, but it's there here. All right, so when we talk about infrastructure, what do I do as a DevOps? I need to create infrastructure, whether on the cloud or on my own data center. Okay, when I say my own data center, it means running my servers myself. Okay, it could be here or it could be in the US, but doesn't matter. With the tools available today, we can access them here as well. Okay, so you need to automate these things. So your company has built a nice project, and your clients are interested in it. So one client wants to build it on their own cloud, another client wants to build it on another cloud, or someone wants to have it built maintained by you yourself. You need to build separate servers for them. So every time you cannot keep on building servers for them. There should be some automation. So that's where we have tools like Terraform, Cloud Formation, and ARM templates. So in this course, we are going to talk about Terraform. Okay, then once you have your servers and routers and everything ready, you need to configure them. You need to make the prerequisite software available on that. That's why we have tools like Ansible, Chef, and Puppet, which will make this software configuration much easy. So in this course, we're going to talk about Ansible. Then the build part, you actually have various tools, but these all can be.
Kiran, 1 second, Kiran.
Yeah.
Can you please tell one more time about the DevOps components? I really missed it.
All right.
Sorry
Okay.
for that.
So yeah, no worries. Let me go back to some drawing. So you have your developers. Come on. Okay, you have your developers who actually build code. Let's say these are your developers' machines, okay, laptops. They all build code, okay, and they all save it in the central location for code. This is called as source code repository. Okay, I'll not go. I mean, it's a very high level view, like a 10,000 feet overview.
That's fine.
Uh,
Yeah.
so yeah, they build it in they build it in a something called a source code repository. Examples are like GitHub and all that stuff. So this code alone will not work. This has to be converted into some sort of uh, binary file, or what you call as an executable file, like APK if it's a mobile app. If it's a Windows app, it should be .exe. Okay, this is called build process. So you build it into an executable which can be run on your servers or on mobile devices. Then you will have to release it to the public. Okay, the public should access this. So this process is called as release. Okay, but where do these things happen? This should all happen in a set of servers, right? So that thing is called as infrastructure, where you maintain your servers and all that stuff. Okay, so you need to build this infrastructure, and you need to build it quite often, maybe, because each client might require their own setup. Okay, so if you're a services company, you have expertise in cloud offerings, so you can set up these services for your client, but this has to be automated. That's when we have the infrastructure as a code tools like Terraform. Okay, so right now to release the software, you have some servers. Just okay, let's say you have your servers here. Let's say you built a Java application, and you're running your Java application on these servers. Mind you, you run the same application on multiple servers because of redundancy and load handling, and the database will be on a different server, like you might using something like MySQL. Okay, so let's say you have to install your code is built on Java, but that has to be run on a pre-existing application like Tomcat. Okay, so Tomcat has to be installed here. Also, you have your MySQL database, but MySQL software needs to be installed on the server. Okay, there might be many other tweaks you need to do to the servers to run your application, make some firewall rules or whatever. Okay, all this thing is called as software configuration management. Okay, that's where you need tools like Ansible, Chef, and Puppet, because it might sound like two servers. I can log into these servers and make changes. No, tomorrow you might have 10 servers, then you have 20 servers. So how do you manage all these at once? You need some automation, you need some tools for that, and that's why we have software configuration coming into picture. We have tools like Ansible, Chef, and Puppet. Okay, and for this build process, we have various tools based on what application you're using. You could use something like Maven for Java applications. Okay, and these tools we'll learn this part of as Jenkins. Not learn these tools individually, but we'll learn this as part of your Jenkins program. Okay, then your
And
release management also.
all these
Mhm,
tools, like whatever you said, like Ansible, Chef, and Puppet, and all this,
mhm.
I mean, the DevOps engineer need all this? I mean, basically, he needs all this. I mean, there are tools, but they need a little bit of Java programming in this.
No, no, not required.
Not
Not at
required.
all.
Okay, so
Yeah,
whatever the software management, configuration management. Okay,
yeah,
even for
no,
the
not
Jenkins also,
required.
right?
No, not required. It's
Okay,
good
got
to
it.
know about how applications are built. Okay, what
Okay,
is the code, what is the binary, and where do they sit. But you need to know nothing about Java programming. Okay, I
got it.
know a little bit
And
of Python programming. Yeah.
okay. Okay, and also in this whole picture, like whatever the life
Hmm.
cycle that you're showing, like build and everything, like where I mean,
Hmm.
where does the cloud comes in this picture here? Because the cloud, I mean,
Yeah. So here it is, infrastructure. So where do you run all these things?
okay.
Okay.
So
So
basically, if it is on-prem, it is like in our side. Okay, got it. Okay,
yeah. So the point of this course is you learn Azure as a cloud, you understand cloud concepts, but these tools like Ansible, Jenkins, and even Terraform, these can be applied for multiple clouds, not only for Azure. That's why I'm not teaching ARM templates. For example, ARM templates is Azure's own offering of infrastructure as code, where you can maintain your infrastructure in the form of code. But I'm teaching Terraform because
mm,
Terraform can be adopted to various clouds like AWS. Okay. Similarly, Ansible is very extensible and easy to learn, easy to adopt. So, and it can be used anywhere, or your on-prem environment, on your cloud environment, anywhere. And you know Jenkins, right? Jenkins is also very popular in the industry. People are using it in many ways. It's an automation server in a way. So for the build and release, we are going to focus on Jenkins.
okay,
For the monitoring and alerting, there are a lot of tools which will monitor your infrastructure. We're going to learn Nagios and Azure Monitor. Of course, we are learning about Azure, so it's good to know about Azure Monitor. CloudWatch is again AWS specific one. PagerDuty is a paid service for alerting. Some of the organizations might use it. My previous organizations used to use PagerDuty and all. We are not going to touch those things, but we'll understand how alerts can be set using Azure Monitor. Okay. So these are the various components within the software development lifecycle. And there is one thing where do you run your server? I mean, where do you install all these software configuration and all this stuff? They have to have a operating system, right? So that operating system we are going to learn is Linux, because Linux is the most favored operating system for running enterprise applications. When I say enterprise applications, from your Google application to Facebook to everything runs on Linux servers. Okay, so that's why we are going to talk about Linux as the operating system. We are going to talk, and where do you store all this code? You need a version control system. So that's where we learn about Git and GitHub. Let me show you that in a gist. Okay, so this is the detail. You could go through this. Okay, but sorry, I did not put it up in a. Just give me a second. It should be somewhere. Have a tabular format of what I teach, so that gives you a snapshot of what we are going to talk in this course. But maybe I've jumbled up my presentations. Just a second, I'll be back. So any other questions in what we have discussed so far? From what's DevOps, what's cloud, and infrastructure, and all that stuff.
Yeah, I mean, so is a class, I mean, basically the demo completed, or you're still having some,
Yeah, I have a few more slides. Just give me a
okay.
second.
Yeah, I mean,
I
go
just
ahead,
want
and
to.
I have some questions, but I'll talk after the class.
Awesome. Okay. Come on. And that's Hare Krishna, right? Hare Krishna.
Yes, yes, yes.
Just a second. I'm trying to pull up that slide. I mean, this all might some overwhelming, so I'll just put this one slide. All right. Okay. Okay. So, do you see my screen?
Yes, yes.
Okay. So this is
Uh,
what we are doing.
Sorry, Kiran, we are not seeing your screen. We're not able to see your screen.
What about others? Do you see my screen? Hello. Anyone
Have you
is?
shared anything?
Yes, I'm able to
Yeah.
see.
Yeah, I'm not able to see.
What about others?
We
You're
are
also
able
not
to
able
see.
to see.
I'm able
Okay.
to see.
Maybe you'll have to click on that window where you see the screen. Maybe you change the view or something. Your GoToMeeting might have minimized or something. Let's check. All right. So what is covered? We're going to talk about operating system, and we're going to talk about Linux, because without Linux, many of these tools would not have been possible, from Jenkins, Ansible to Docker and all these things. Okay. And it is the most, widely used operating system in the world today. I can go on about Linux. Okay. And then of course, cloud. That's where we are going to implement all these things. Then we are going to learn about version controlling. We'll learn about Git, and source code repository will be GitHub. Infrastructure as code, we'll learn about Terraform, how to automate creating your infrastructure using Terraform. Continuous integration and delivery, that's nothing but the build and release process, we'll learn through Jenkins. And software configuration management, we'll learn Ansible. Containers and orchestration, this is the next level of virtualization that's taking up. You might all have heard at least once Docker and Kubernetes. Okay, so these are the niche technologies. And a word of caution here, or just a what do you call disclaimer. We're going to do Kubernetes as only 101, Kubernetes 101, meaning very high level, because this itself is a very deep topic, deep and wide. So we cannot cover all these concepts within this course. So I'll just give you a overview of Kubernetes. Maybe later you could start learning on your own, or maybe I'll start another course on Kubernetes exclusively. We'll let you know. Okay. Then the monitoring part, we'll learn about Azure Monitor and Nagios. Okay. Don't worry if you don't know about any of these things. We're going to talk about each of these things in detail, and it's as I mean, uh, I teach them. I tell you what each of these tools do, but it's up to you to practice and gain more knowledge and come up with questions. Okay. So this is what we cover in the course in a snapshot. And while teaching each of these, we'll also talk about theory and also the practice. So you might ask me what are the prerequisites, minimum requirements. You need a computer with system administrator rights. Why system administrator rights? You need to install some tools. Okay. Azure free tier account and a backup account. What do I mean by a backup account? The course is aimed for 50 days, but sometimes it might spill over up to 55 days as well sometimes, because I'm a human being. I might take breaks, in the sense I might fall sick, or I might go somewhere, or anything. So the course might as well go up to 55 days. Okay. In that case, Azure offers only free subscription for 1 month. Later, you will need to start paying. Instead, if you can create a backup account, that will be awesome. So you would need a different email address and a different credit card, because unfortunately, Azure subscription can be opted for only if you have credit card. No billing. It will only for it is only used for verification. You won't be billed anything. So it's good to have one account at the at this first week or second week of your first week. Okay. And a backup account after 3 or 4 weeks, because you'll need to do more practice on Azure. So you might take your spouse's card or your friend's card and your friend's email account and create a backup account. Email account is fine, but credit card is where you have to be careful. Okay, these are the minimum requirements. A backup account is like optional, but I would still recommend go for it. And what's good to have? Appetite for learning, of course. You need to have good appetite to learn, to practice, and quality daily time for practice. So take some time off your day and practice. These are the prerequisites. I did not put coding, I did not put programming. Okay. Any questions? Or if you want me to finish it off, I'll finish, then you can ask your questions. All right. So to put it in a nutshell, what I've been telling this entire hour, this course aims to introduce the application lifecycle management with emphasis on IT operations and DevOps toolchain. Okay. So we talked about application lifecycle from the operations perspective, not from the developer perspective, not from the programming perspective, but how do we take this programmed code and put it into production, and how does DevOps toolchain works. This course is designed for both beginners and also experienced IT professionals. This course aims to equip the participants with the right amount of theoretical and practical knowledge of DevOps practices and tools, and also Azure, of course. While this course offers a lot to learn and upskill, it is the individual participant's appetite and practice that lands her in the right role. Because you're going to ask after this course, am I going to land in a super cool DevOps job? I don't know. It all depends upon how you practice and how you take the inputs from my class and keep building on it. Okay. That's about my demo, and it's over to you now.
Yeah, my question, I'm Kiran, right? Your name is Kiran, right? Okay. My first question
Yeah.
is like basically, do we need any I mean, you already said we need an Azure account or something to practice, right?
Yeah,
And
yeah.
we need any computer other than, I mean, basically any high-end computer to learn all this, or just a account with Azure is enough for me?
Yeah, you don't need a high-end computer, but don't get, it should not be even frustrating to you. If it hangs every 2 minutes, that gets frustrating. So maybe
Okay.
something like a computer with i3 and a 4 GB RAM, because
Okay.
that's become minimum these days. Or a 2 GB RAM would also do. But again, yeah.
I heard like there are some labs in India where you can subscribe to labs, and we can basically practice all Jenkins and everything, even Hadoop and everything. Also, we can also practice there, and from there we can also connect to Azure or basic cloud or something if you want to practice that way.
See, when you're doing all these things, the point is to learn Azure, right, Hari
Mhm.
Krishna? So
Okay.
the point is we will do all this on Azure. So you'll connect to Azure computers, and
Mhm.
e- everything is running on Azure computers. So you need
Mhm.
not have super nifty high computer. It's like working on the labs itself. But
Okay.
here, what the challenge with the labs is, they will set up a lot of things for you. Here, you will set up those things for yourself. So there's a
Got it.
learning there as well. Yeah, the
Okay.
installation and
So better,
configuration part
better,
we'll
better
do.
to have, because right now I don't have any computer. I am using my office laptop. So if I do that, I'm not sure like whether I can able to connect from my office network to Azure and everything. That's the reason why I'm asking this.
Yeah, Azure, generally they don't block it because most of the companies open star.microsoft.com, meaning
Mhm.
you should be able to access. And
Okay.
only thing is there are a couple of tools you need to install.
Mhm.
Because we are learning all this on a Linux machine, on Linux machines, you need a tool
Mhm.
called as Git Bash.
Mhm.
Okay, and another thing is optional. You may or may not install it. It's called Visual Studio Code, which will help you to write code easily. Okay,
Got it. Got it.
I
Yeah,
mean,
I
code
understand.
in the sense we are not programming, but we need to do some. Yeah. Another question I generally get is, do I need to do coding? Not really, but if you look at this one, Linux is all
Mhm.
about command line. No GUI. You will not click here and there. You'll for even for rebooting, you'll do a command. You'll apply commands. So everything is
Yeah.
commands in Linux.
Yeah.
So you'll do a
I
lot
mean,
of typing.
I'm doing Linux from last 17 years. So I'm a basically ETL engineer. Like I've been working on a lot of ETL tools like Informatica, DataStage, and Cognos, and a lot of reporting tools. I'm a basically BI engineer actually.
Yeah,
So I have very good knowledge in Linux and all this scripting languages.
yeah,
Uh,
awesome.
yeah.
You could teach me a thing or two.
No, 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 not like that. I know it, but not like I'm able to handle it. That's what I'm. But
No, no,
Java,
yeah,
I think, like I can say
yeah,
it's zero. I can say zero.
yeah. No worries. Yeah. I mean, I'm talking in general terms. So we'll do a lot of typing here, and Terraform is about code. So we'll do a lot of typing. You need not learn a new language. You just need to understand how it works. Uh, Jenkins, it's mostly UI, but it's better to learn some scripting. I'll tell you about that. Ansible again is written in a language called as YAML. Okay, just like I shown you earlier. So it's also typing, but doesn't mean you need to create everything from scratch. There are templates and everything available. Okay,
Mhm.
you'll do a lot of typing here as well. So there's a lot of typing to do, but you know I'll teach about, when we talk about Linux, we talk about bash scripting as well, how to write scripts and automate stuff. Okay,
Okay.
so there will be a lot of typing, but coding is not required. But we will teach bash scripting, and again I'll teach the basics of bash scripting. It's for you to explore and create more scripts out of it. I'll give you tasks periodically. You can you know practice doing those tasks, and you'll learn a lot.
Okay. One more question I'm having is that not only this one. So it's like it's going to take 2 months, right, for completing all the course.
Yeah.
Okay, got it. 2 months. And I basically see in my I'm talking about in my environment. Basically, we are basically going to Azure, and they are
Hmm.
using Azure Databricks for building some Azure data warehouse.
Hmm.
So you're not going to teach any Databricks, right? Here?
Yeah, that's a good question. So I'm not going to talk about, these are all managed services. Okay,
Mhm.
so we're going to talk mostly, as I said, infrastructure services.
Got it.
Like
Okay.
um we'll talk about virtual machines,
Uh-huh.
virtual networks.
Mhm.
Okay, virtual rather storage. How do you use storage in Azure? Network security. Okay, how do you implement firewall rules in Azure? We'll talk about identity and access management, like how to create users, how to assign permissions, and all that stuff. Okay, and here we talk a little more about so load balancers, subnets, everything will come. Virtual networks, I mean, part of virtual networks.
Basically,
We'll
like
talk about this.
whole Azure infrastructure, everything.
Yes, so it's mostly focused on the infrastructure as a service. We have three kinds of services in any cloud. You might have heard these things. One is IaaS, infrastructure as a service, where you actually rent physical servers and use them. And then there is PaaS, platform as a service, and there is SaaS. So I think your Databricks will fall somewhere like PaaS kind of thing, which is you don't have to configure a lot of underlying things. You'll just use your code, and Azure will take care of other things. Okay, so no Azure Databricks, but some of the things might be useful for you, like identity and access management, talking about network security in Azure. Okay.
Okay. And
And
for
storage.
learning, I'm extending my question. Like for learning Databricks, I need to have a basic knowledge of Azure, right?
Yeah, it's always good to have how to, what we also talk about what is Azure subscription, what is Azure tenant, how do you create resource groups, and all these things might be useful for you too.
Got it.
Yeah.
Okay. Nice to have it. And who is going to basically? Are you going to tell? I mean, how much is going to charge for this one? Like, what is the amount and everything?
Career IT folks will get back to you. I think they might have sent you the email and all that stuff. So they will.
Okay.
Is
it daily class or weekend classes?
No weekend classes, only weekday classes. So Monday through Friday. I would like to, do it that way. 5 days a week.
5
So
days
how
and
long it will be?
same time.
No. Again, Career IT folks will inform you. I think it's going to be early in the morning, 6 to 7.
6 to 7
IST.
means your time or my time?
IST. Sorry. So you're from EST?
EST, yes, yeah.
So what would that be? 7:30 p.m.
8:30 now.
No, 6 a.m. Indian time.
Yeah, 6 a.m. equal to 8:30 p.m.
8:30. Yeah. I'm calculating the daylight time. Yeah.
8:30 p.m. Right? I'm
So
fine
how
with
long
that.
will the session be, Kiran? Every day? 1 hour?
Mostly 1 hour, 1 hour 15 minutes. Sometimes
Okay.
it might spill over to 1 hour 30 minutes because I don't want to leave some topic in the middle, so it might
Yeah, that's
extend.
fine. At a max, like
Yeah.
1.5 hour, right? Okay.
At the max. Yeah, that's the max.
Yeah.
And maybe down the line, like after midway through the course, I might little move to 7 to 8 because uh, there is some constraint for me right now. I have a hard stop at 7:15. So, but later I might move it to 7 to 8 p.m., 7 a.m. to 8 a.m. Sorry. So that's later. Maybe may or may not happen. That depends upon all of your consensus as well.
Okay, fine.
Yeah.
Okay, got it, sir. Thank you. And I mean, basically, after this course, are we able to write any certifications?
Okay. So here's the thing. This course has a lot of things in this. Okay. So straight out of this course, you cannot go and write a certification. But what you can do is, with the basics you learn from Azure, you can pick up a something like Azure 103 and do some 15 days of intense study, and you can take any certifications like Azure 103. But straight off the course, this doesn't, because this is not focused entirely on Azure administration. This tries to cover a wide range of subjects, as you can see. So
Got it.
yeah, straight out of the course, I wouldn't say no, but it would give you a nice gateway to this cloud computing in general and the DevOps world, and you can start picking up on any of these. I mean, mostly Azure 103 or Azure. You have various programs. They've changed the names.
And I'm asking so many questions. My other
Yeah, no
question is
worries.
like, what type of job roles we can apply like after these courses? Like, I'm not only after this course, like at least what are the trending jobs in cloud areas right now?
Okay, so you would see a lot of roles like cloud ops, okay? And of course DevOps engineer, and there is something called as site reliability engineering. I talked
Okay.
about. Someone asked me about the book. This is the book. I don't remember who asked it. Site Reliability Engineering by Google. This is the book which talks about DevOps practices and everything. Okay, so all the cloud ops, DevOps engineer, site reliability engineering, many of them have overlapping areas, or
Okay.
some companies might have completely different understanding of each of these. Cloud ops, you don't see it too often these days, but mostly DevOps and site reliability. It doesn't matter what it says, but it depends upon what their tool chain is and what is their level of maturity in implementing these technologies. You should see their job requirement.
Got it.
Okay, do they need someone with some Linux experience, with Ansible and Jenkins, okay, and Terraform, with knowledge of Kubernetes
So
or Docker?
all this and
You're a
all
good
this you're
candidate.
going to cover all this. You're going to cover all this, right? I mean, not Linux. I'm sorry. I'm talking about Ansible, Jenkins, and
Yeah,
uh,
even I'm going to cover Linux in the first week mostly.
okay.
Yeah, maybe 2 to 3 classes where we learn about how to install stuff and all that, because without learning all this stuff you cannot configure Ansible and Jenkins and even
Got it.
Docker to an extent.
And
Okay,
also Docker
and
is very
let's
big subject, right? I think you're not covering completely, right? Docker.
uh, most of the concept, yes, I'm covering, not advanced networking and all that, but yeah, you'll good to say that you worked on Docker after our course.
Sure.
and and let's say
Even this is
you
specific.
another job might have all these things. Oh, 1 second, okay, let me complete this. Another course might say Linux, Chef, Jenkins, Terraform, Docker, or might not even say Terraform. Okay, but you're still a good candidate for it. You might not know Chef, but you could convince them that you have good understanding of Ansible. They'll definitely prefer you. Okay,
Okay.
so there are a lot of areas where we talked about, and all of these people will mention, of course, your knowledge about Git. There are a lot of areas, and you need not be a champ or a 10 out of 10 on each of these areas. Okay, let's say you have very good knowledge on Linux because of your previous experience or whatever. You are 8 of 10 here, and you are 7 out of 10 here within the limited services you learn, because no one can learn all the services within Azure. Okay, within the limited services, you say, let's say you're 7 out of 10, and here you're like 6 out of 10, here you're just like 5 out of 10. It doesn't matter. If you can prove your expertise in at least 2 to 3 areas, he will be impressed with you. And if you have good understanding of other areas, he will definitely, I mean, he or she will definitely consider you, the interviewer.
Got it. Got it. Yeah. Thank you.
Hi, Kiran. This is Venkata here.
Yeah,
What are the topics that you are covering on the Azure side?
okay, I've already mentioned them. So we are going to cover infrastructure services. So we will talk about what is Azure from the Azure accounts perspective. What is a subscription? Okay, what is a tenant and all this stuff. Then we're going to talk about Azure virtual machines, Azure virtual networks, load balancers within the virtual machines. Again, it's a long virtual machine scale set, availability zones.
This is
Yeah,
kind of administration side, right? It's not into development side.
not into
Not checking
development side. No,
databases.
no,
Okay.
no, no,
Okay.
not into development.
Okay. So thank you.
Purely from the DevOps perspective, what a DevOps engineer requires when he goes into an organization where Azure is their preferred cloud, or Azure is their primary cloud.
Okay. Okay. So if I want to go to that Azure development side, so
Mhm.
still we need this knowledge on DevOps, right?
Uh, it I cannot really comment on that, because as I said, this course again aims to make someone to be able to apply for a DevOps role,
Okay.
or find internal opportunities with DevOps. So I cannot really comment if you would need this or if you don't need this. But again, I'm going to give a lot of insights into how Azure infrastructure works and all that things, which a developer needs to know, no doubt. Okay,
Okay.
but
Okay.
some developers might say, might feel that they need to stick only to the development part, and they need not venture into the areas of release and build and release, for instance, or the infrastructure side, they might think that this will be taken care by ops engineers. So yeah, it's perspective again, however you
Okay.
want to go. Yeah.
Okay. Thank you.
Yeah, you're welcome.
What is the difference between Azure and Amazon? Like, um I mean, I know some companies prefer Azure and some companies prefer AWS, right?
Yeah, so it's like two different vendors like Flipkart and Amazon. You might have the same services here and there, maybe pricing differences, maybe geographical differences. I'll tell you what, AWS started in 2006. Okay, and by 2010 they had good market share already. Okay, so a lot of SMEs, when I say SMEs, small and medium enterprises, and even big enterprises have jumped on the AWS bandwagon. And another good thing about AWS is they have made their adoption much wider, in the sense they used they did intense marketing, like their conferences, everything was intense. So a lot of market share was gained by them by the time even others are thinking about cloud. So I think Azure initially launched in 2010, but that was a very slow start. Gradually picked up in 2013. Again, they messed up something. They introduced something called as Azure Service Manager initially. Then they tried to run something parallelly called as Azure Resource Manager. So there was some, not very clear as AWS. So they lagged behind. But think about these things. A lot of companies have been having agreements with Microsoft from long for their Office subscriptions, right? For their Windows subscriptions. All these, there are a lot of big companies which have tie-ups with Microsoft from a long time. They have long-term contracts like 10 years, 15 years, 20 years. So now these companies, if they want to move, they would move to Azure rather than AWS, because they already have an existing account with Microsoft. It's like known beast to them, rather than going to AWS. Okay, so that's why Azure claims that it is growing faster than AWS. AWS still might have highest market share, but Azure claims it's growing faster, meaning it is acquiring more number of new clients rather than AWS. Okay, but again, these numbers are not very clear. Both are going neck to neck in the competition. Again, differences in services, differences in regions. For example, your business might be in California, so that's called US West in most of the clouds. So Azure has some services in US West and AWS has some services in US West. Maybe whatever services you're looking for, that is available only in AWS and not in Azure, then you might choose AWS or Azure. Or pricing could be a factor. In some services, Azure has per minute billing. So if you use a VM for 1 hour and 5 minutes, you will be charged for 1 hour and 5 minutes only. But in in AWS, it will be 2 hours billing. So some of these considerations might also will uh, make customers think about which cloud to go. Okay, and some people just the comfort, like they might have already been very comfortable with AWS. They don't want to shift their workloads to Azure now.
Okay, yeah, okay, I got it. So, and how about the learning curve when compared to AWS to Azure? I mean, yeah, you go ahead.
Yeah, see, these concepts are all the same on. The names changes. For example, what you call virtual machine in Azure, in AWS is EC2. Okay. What you call virtual machine scale set in Azure, you call it as auto scaling group in Amazon. The concept is same. Okay, the concept is same, but the implementation might vary. Uh, Ease of use, I'll be honest with you, Azure is trying to make the portal better, but AWS is easy to use in a way. Okay, but maybe that's because I've been using it from a long time rather than Azure. But in either case, it's the concept is similar. You just need to understand the concept behind it, and maybe the naming, the nomenclature changes from there and here. Okay, storage, for example, you have here disks. Okay, there you call it as EBS in AWS. You have what do you call as blob storage here. There you call as S3. Okay, so then the concepts are same. The underlying technologies might also be the same, but the implementation slightly varies, and learning curve is equal for both of them. I've taught AWS as well, uh, so I don't see much difference. But again, you need to have your focus area. You need to focus on your infrastructure as a service. If you want to learn the entire Azure, that's a wild goose chase. No point. So you have to narrow down on what you want to learn and learn it well. That's my funda. So then I don't see much difference between the learning curve between AWS and Azure. And once you learn Azure, and let's say you want to also learn AWS, maybe 1 year down the line, uh, then it's not a big challenge for you, because now you understand how the networking works, how the firewall rule works, how you can SSH into these servers. So since you have a lot of understanding on Azure, it will become easy for you to learn AWS. And I would dare say that without anyone's help, you can learn AWS after some time. I mean, maybe after 3-4 months of practicing Azure rigorously, you can go to AWS, open an AWS account, and learn by yourself, like looking at the documentation. Okay.
Okay. And another thing is, what are the typical job responsibilities once you take up some DevOps engineer position?
Yeah, very good question. So this again varies from company to company. Some companies might want to do from what we call cradle to graveyard. Understand, right? Right from the birth to death, like create infra, configure it, okay, build and release, monitor, maintain, like patches, upgrades, everything, decommission. So if it has come to end of life, you have to also decommission it. Okay, this is what we call cradle to graveyard. Uh, there are some companies which might do only the configuration management and build and release. Maybe monitoring is done by their network operations team or some other team. Okay, maybe maintenance also you'll do. Okay, some companies
Okay.
might
Can you
name it
can you
as
take an example? Can you take an example?
like what sort of example?
I mean, like suppose like if I join some company, right, and they have recently moved to Azure. So what am I
Mhm.
supposed to do there? Like whatever project they are running, do I need to do
Okay,
weekly?
let's say you joined a company called as Tech. Okay, some imaginary company. They've recently moved to Azure. Okay, so let's say they have clients, and they have to spin up a cluster for each of these clients. Cluster in the sense, you have to build their own servers to run the application for the client. Okay, so then you use something like Terraform to build their infrastructure. Okay, so you just write code which will automatically build your servers, build in the sense create servers on Azure. Okay, and then you will use Ansible to do some configuration management, update the servers with some details and all that. Okay, and then you'll use uh, then the developers will build code and put it in their own repository like a GitLab or GitHub, wherever it is. Okay, then you have to build release and pipeline. Okay, sorry, build and release pipelines on Jenkins. Okay, or maybe some of these are already set up for you. You just need to go and use the Terraform scripts, modify them to your requirement, and start using it. Maybe they already have Ansible playbooks. You just need to modify them and use it. Or if they're setting up a new company, you might have to do it all yourself. Not new company, new practices in Azure. Okay, so all this you're going to do Azure. So to build infrastructure using Terraform, you need to understand what is a virtual machine on Azure, what is a virtual network on Azure, what are its dependencies, okay, what are the various pictures that come into play. You need to understand all these things. Okay,
But
so
this is a one-time activity, right? Like you set up the infrastructure and you do the configuration management and the build and release pipeline. You set it up and it
okay.
goes on,
So
right?
exactly. But do they remain static? Will the load increase or not?
Yeah, it
Uh,
increases.
any business expects its business to expect. Let's say because of all the new regulations, they built a site in US region. They want to move their business to Europe. They have to create this again in Europe. You have to do the same setup again in Europe, right? And we're talking about one client, and most of the companies will not be sticking with one client, right? They'll move to other client, even if it's a services company or a product company. Let's say in the previous company I worked, it's a machine learning company. Okay, so they have their own product. There are two offerings to that. One is SaaS product. What is SaaS product? You run your application on your own servers. Clients will directly access through a website. Another one is you build on their servers. Okay, the code is yours, but you take this code and you configure it on their servers. So every time a new client comes, for example, uh, an insurance giant will come to you, someone like AXA, okay, and he asks, okay, I like your build machine learning application, but I don't want to set it up on your own computers. I want to set this same setup on my systems. Okay, so then again we use these tools, Terraform, Ansible, which is already pre-written, maybe, or maybe we need to refigure it, or maybe he has his own data center. Again, we have to rework on that. So we will set up for AXA right from scratch to till the time you deploy the application and give it to him just like your own application. Okay, then you will set up monitoring on this. In the meanwhile, you will also monitor this application. Okay, you might have to do on-call duty, and your teams will do changes. So every time there's a change, you will have to release it. Okay, so this is continuous process. This is one thing that is going on continuously as a DevOps engineer. Then again, after this project is done, maybe another project is coming with some banking client. Okay, let's say Citibank wants to come and says, hey, I like your machine learning product, set it upon my private cloud, meaning his own data centers, or maybe he wants to set it upon Azure. Okay, so again you do the drill, but this time it becomes much easier. You have already a lot of learning to do, but again there are tweaks to do, there are changes to do, and maybe your original application might have also changed. So you need to change something in your Terraform code, or you might to change something in your Ansible playbook. Okay, or maybe some services in Azure changed, you have to adapt to that. So this is a continuous process. It's not like you set up once and forget it.
Okay, so even though you automate the stuff, still you'll have some maintenance activities to do on it, right?
Yeah, that's what I talked about, releases, right? Time and often you need to make changes to your application, you release it to the market. You might have to do it on your, and when you when you deploy the code onto your production systems, where is the picture? I think it's gone. You don't do it directly onto the production. For example, when you set up your infrastructure for AXA, you don't set up on their production servers directly. There is a life cycle for this. For example, you have to build it on the dev servers first, test it, then move to something called as staging servers. These are not available to public. These are only available internally to AXA and you. Then finally, you will move it to production servers. So you have at least 3 stages where you go for each product. Even on your existing product, which you don't change the infrastructure quite often, but these 3 stages exist. Okay, these three set of servers with a similar setup. You have to go through this process every time. Sorry, what happened?
One question.
Product.
So where does the DevOps? I mean, where does this Kubernetes and Docker will come into this picture in this life cycle?
That's a good question. So we talked about virtual machines, right? Yeah, forget Terraform and everything. You talked about machines, right? Okay, so so earlier what used to happen, you build a virtual machine and you install your application on it, you make it your web server. Okay.
Hi Kiran, sorry to interrupt you.
Yeah.
Hi all, a small info from Career IT. The batch is starting from Monday onwards, that is 23rd March IST. And the timing would be 6 to 7 a.m. IST. And I'll be sending an email also along with today's recording. So please do check your mails, everyone, for the other details. Thank you.
Yeah. All right, so this is going to take a few minutes. Let me try to do it, wrap up
Sure.
quickly. Yeah, so you have your traditional approach of deploying applications.
Mm-hmm.
And again, systems, you always assume that systems fail anytime. So if you're running your application on single machine, it is a single point of failure. So you want to divide the load between two servers. And you don't run all the components on the same servers. You have your web section, like your web server, like Apache or Tomcat, and then you or Nginx, and then you have your DB. At least two layers are two layers are present, sometimes more than two layers, or we call it as tiers. Okay, tier,
Mm-hmm.
web tier and DB tier, and each of these things runs an instance of Apache. Okay, or let's say Tomcat. Okay, so this entire server can run only this Tomcat because it's not good to run DB on this server. Okay, and sometimes the load might be high, sometimes the load might be low. So what happens is a lot of your uh, virtual machine might be underutilized. So then came the concept of operating system level virtualization, or what we call as containers. So within a VM, you run a mini VM. Okay, a Docker container is something like a mini VM, which has it doesn't have its own operating system, but it behaves as if it has its own operating system. So instead of running one instance of web, you can run two Tomcats instances. Okay, same is the case here as well. So you have uh, better utilization of resources. That's one point. And then another point is there is something called as works on my machine problem. You might have heard of it. In the sense, when developers initially build code, they build it on their local machine. On when I say local machine, on their own laptops. Okay, and they test it and they push it to operations team. They say, hey, I built this code, it's working perfectly fine. Go ahead and deploy in your development servers. Okay, I deploy in development servers, bang, error, it doesn't work. What happened? Because when developer tested it on his laptop, maybe he's using some Java 8. Okay, he might be using Java 8 on his laptop, but on the development server there might be still Java 7. So there is a mismatch. So again, we have to push it back to developer. Developer again insists it works on my machine. You go fix in your computer, your operating systems or your servers. Okay. So this is a game that used to happen. Now what happens is with these containers, not only the code, but you also encapsulate your dependencies. For example, you're building a Java application. You not only have the Java code, but the dependencies. For example, if it requires Java 8, it has to be there within this container. If it also requires something like OpenSSH or whatever, any dependencies, it will also come with this dependency. So you pack together as an image and send it to your development team. Development team need not do anything. Take the same image and run it as a container. Okay, meaning as a mini VM. So it solves this works on my machine problem, and this can be deployed in any virtual machine which runs any type of Linux machine. For example, developer might be working on MacBook. Okay, developer might be working on MacBook. Everything works well on this, but here you might have Ubuntu machine. Okay, Ubuntu is a Linux, one flavor of Linux machine. Okay, and you might have another set of servers which are running Red Hat. Red Hat is another set of Linux operating system. So this works all fine here. Okay, your code, but when you move to Ubuntu, that might crash. But with the Docker images, what you do is, it's, as I said, it's like a mini operating system. It also has a base image from Ubuntu or something. So it also has some binaries which are, you know, of the operating system. So no matter whether you put it on Ubuntu machine or a MacBook or a Red Hat operating system, it works the same way. So this concept is called build once, ship anywhere. Okay, so this has been made easy by containers. It is not easy to do that on a virtual machines. Lot of dependencies are all figured out within this small image, okay, which can be deployed as various containers. Containers are nothing but mini operating systems. Okay, So there's a lot to cover about it, but we'll come to that later. That's my 2 cents on it. So you could say this as Docker is build once, ship anywhere. Their funda is build once, ship anywhere. That's why you see the Docker containers. So what's the concept of a container? Some items might be round, some items might be square, some items might be whatever shape. But you put that with all the packing inside a container and you ship the container. Okay, and when you unpack, you know what it's inside. But for outsider, all the things are put in a container. It can be put in any vessel. It can be put in a big truck or it can be put on a ship as well. So that's the concept of containers, which will make development easy and also deployment much easy. Kubernetes is the next level of Docker. Kubernetes takes these things and orchestrates in the sense, makes connections between these various containers easy and runs it as a single application.
Got it. It's a high level, yeah.
Yeah, very high level. Without Docker, Linux concepts, you cannot directly understand it, but yeah, we'll come to there.
Thank you. Thanks for the explanation. I like your presentation.
All right. Any other questions?
Yeah, I'm good with the questions. Yeah, I'm very much interested to join the course. Yeah.
Awesome. Yep. Anyone else has any questions? All right, then, if you don't have any questions, have a good Saturday and stay at home. Take care.
Thank you. Bye.
So thank you. Okay.
Thanks, everyone.